Welcome. This is the professor, Daniel Fritz, Mathematics, Trigonometry, Pre-Calculus. And we're going to talk about finding the exact value for the trigonometric function for any angle. Let's look at the definition. Let theta be an angle in standard position and let the ordered pair AB denote the coordinate of a point except the origin 0, 0 on the terminal side of theta. And if r is equal to a squared plus b squared denotes the distance from the origin 0, 0 to the ordered pair AB, then the 6 trigonometric functions of theta are defined as ratios provided no denominator could equal what? 0. And if the denominator equals 0, then the trigonometric function of the angle theta will be what? Will be undefined. Now let's look at the graph for a second, and this is represented with the first quadrant on the Cartesian coordinate system. And here we have the point here, AB, and from this point here, from the origin stretching to point AB, which we have the long side R, and of course this representing the adjacent side of theta, and this represents the opposite side of theta. Kind of reminds you what's getting together here, what's being derived as the infamous Pythagorean theorem. R is equal to the square root of a squared plus b squared. Now, with this, having this display gives you our trigonometric functions in this version, which is the same concepts across the board, where you have sine theta is equal to b over r, cosine theta equals to a over r, tangent theta is equal to b divided by a, and of course cosecant, secant, and cotangent are your reciprocal identities. You see this? So here we can find the exact values with these trigonometric functions. Now, just going over here to this display, this graph represents a triangle, similar triangles, that is in the second quadrant of the Cartesian coordinate system. And from this point to this point representing the absolute value of A, and this point to this point representing the absolute value of A prime. And the reason being is because when you deal with distance, you know distance values are not negative values. If you continue on and you notice here on the long side, this is R is similar to the distance of R prime. And of course, B is similar to the distance of B prime as well. So we set these things up as ratios, and then of course we find our values, or we derive our trigonometric function from that. And then we'll do a problem. We'll do a basic problem based on what we have here, based on the point here from the origin to some point AB. So let's look at this. Find the exact value of the 6 trigonometric functions of theta given a point on the terminal side. This is what this video is about today, right? This segment. And the problem will be is to find the exact value of each of the trigonometric functions of a positive angle theta, and you have point 4, negative 3 is a point of the terminal side. Now, follow me, and I will show you the graph, and then we'll show you the setup of the problem. So, for points, AB is equal to what? 4, negative 3, and we have A is equal to 4, and B is equal to negative 3. So we set it up, of course. We set it up, and we plug in those values, finding the what? The missing side. And our missing side is our long side, is our what? Is our hypotenuse, if you will. R in this case. If you go ahead and plug those values in, we get the square root of 25, which gives you the value R is equal to what? R will be equal to 5. Now, setting up the trigonometric functions, our values, of course, we have negative 3 over 5, for sine theta. Cosine theta, we have 4 over 5. And then for tangent theta, we have negative 3 over 4. And of course, for our reciprocal identities, taking the reciprocal r over b, and of course r over a, and a over b respectively, we get these values. For cosecant, negative 5 over 3. For secant theta, we have 5 over 4. And for cotangent theta, we have negative 4 over 3. Well, this concludes our beginning segment, and we're going to continue on with the next segment of our talk when we find the exact values of trigonometric functions. So that'll be on the next segment, and I'll meet you there real soon.